All right, welcome everyone. Today we're going to be looking at solving systems of equations by graphing and substitution. In this first video, we're going to focus all on graphing. And systems of equations are where you have two or more lines or you have two or more equations, and usually we use them to figure out when things will equal each other. So we'll see later on, probably in third quarter, we'll do some word problems where you can see how you can use these kind of in a more of a real world situation. But there's really three things that can happen when you graph a system of equations. The first one is you can get one solution, like you're going to see your lines cross at one spot. The second case you could have is no solutions. If you have parallel lines, lines that never will cross, well, then you won't have any solutions. Or if you have the same line, well, it's touching everywhere technically, so that would be infinitely many solutions. So when we talk about solutions, just keep in mind, we're talking about where the graphs touch or where they're the same as each other. In Delta Math today, you're going to see all of the problems are going to be this first case where you're going to have one solution. But keep in mind, one question that I am going to ask you on your midterm is, what are the three possible cases you can get when you graph systems of equations? So these would be the three cases here. So let's look at a couple examples from what you're going to see with the graph in Delta Math. The first section, level 1, you're going to have all of your equations as y equals mx plus b. Level 2, you will have to solve one of your equations or get it into y equals mx plus b. So these are not bad if you remember how to graph lines that we saw earlier in chapter 2, and you definitely graphed some lines in previous math classes, but I know it's been a while, so we'll do a quick refresher. Remember, the m is your slope or your rise over run, and your b is your y-intercept, and that's where it crosses the y-axis that goes up and down. So you really just want to graph these one at a time. Obviously, in Delta Math, you'll just kind of click 2 points, like you'll click your y-intercept and then do your slope one time, and it will draw the line in for you. But for this first one, I would go down to -7. You always start with your y-intercept. So since it's -7, I go to -7. And this is a good problem to see because our slope is -6 over 5. So that means go down 6, right 5, right? Unfortunately, if I try and do that on this graph, -6 down 5, that would be like somewhere over here, right? It's off the graph. So one thing you can do if it doesn't fit on your graph, your slope, you can always do the opposite. So instead of going down 6, right 5, you can go up 6. So up 1, 2, 3, 4, 5, 6, and then go left 5. Just do like the complete opposite. 1, 2, 3, 4, 5. You won't always have to do this and go backwards. Just keep in mind, like, this is only if it doesn't fit on your graph. So for example, like this one, like I said, my slope was telling me to go down 6, right 5. So since it didn't fit, I just did the opposite. I went up 6, left 5. But in Delta Math will automatically draw in these lines for you. And then we'll graph the second one. I'll do this one in a different color. So with this one, I start up at +1, and then my slope is 2 over 5. So I go up 2, and then I go right 5. So that would be over here. And like I said, once you click your 2 points, Delta Math is going to draw it in for you. And then what you're going to type in Delta Math is the point where they cross. So the point where they cross is -5, -1. Make sure when you type these into Delta Math, you got to put the parentheses around your point or your ordered pair, or I believe it will mark you incorrect. And like I said, when you're actually doing this on the computer, you're just going to click 2 points. It will draw the line in for you. So just click your y-intercept and then do your slope one time. Okay. Level 2 will be a little bit trickier in the sense that one of your equations, you're going to have to get the y by itself. So in the second example, the first equation is ready to graph, that we do have y equals. So we can just go ahead and graph this one. So I would start down at -1. So always start with your b or your y-intercept. And then the slope in this one, it's -2. But remember, that's really -2 over 1. So I'm going to go down to right 1. So down from that y-intercept, I'm going to go down to right 1. That would be here. So my first line would look something like this. This second equation, before I can graph this 2x minus 3 equals negative 21, I have to get my y by itself. So I'm going to, give me one second. I'm going to copy this down below and give myself a little bit more space. All right, sorry about that. I just wanted to recopy this so I'd have some room to work this out. You might even want like a separate sheet of paper to work this out, but we want to get y by itself. So the first thing you always do is get rid of the x part. So since that's positive 2x, I'm going to subtract it to the other side. So then I would just have the minus 3y on this side left over. And then on this side, you always want to, I usually kind of switch the order. You can't combine this, like you have 21 and 2x, like they're not like terms. But I usually try and write it in the order mx plus b. So I'm just going to write what we have. We have that minus 2x or negative 2x because we subtracted. And then we have the negative 21 would just be like minus 21. So you can't combine them, but I just kind of flip the order around just so it's in that mx plus b. And then to get rid of this negative 3, you're just going to divide both parts by negative 3. One tip with the slope or the m part, you're just going to want to keep it as a fraction. One tip though, since we have a negative over a negative, we could just keep it as, we could just make that 2 over 3 because like the negatives would cancel out. And then with a calculator, you really have negative 21 divided by negative 3. That would be positive 7. So now this is something we can graph. Once you get it in y equals mx plus b, that is something you can graph now. So if I go ahead and graph this on my thing, like I said, you would click a point up at 7. And then our slope was 2 over 3. So I would go up to right 3. And then I would just graph that. Sorry, I got a little bit sloppy, but you won't have this problem in Delta Math because it's going to graph the lines for you. But it's kind of off on my graph here in like on the Zoom in this video. But if you graphed it like in Delta Math, you're going to see that it crosses at negative 3, negative, or sorry, not negative. It's sorry, negative 3, positive 5. I know it's not exactly like that on the graph I drew. It's because I was a little bit sloppy. When, like I said, when you're in Delta Math, you're going to click 2 points. It'll sketch it for you. So that will not be a problem. Like you won't like get anything that doesn't look perfect when you look for where it crosses. So that's how graphing's going to go. Most of the problems in Delta Math that I'm going to assign are going to be like the problem on the left or the first problem we did. And I'll put maybe